Okay, this question asks you to balance an equation involving the combustion of benzene, C6H6. So let's go ahead and do that. I have, let's see, I've got a situation here where I'm going to get into an even odd with the oxygens. So I can approach balancing by starting with a 6 in front of the carbon on the product side. And that would get me then 3 in front of the hydrogen on the product side. 2 times 3 is 6, and now carbons and hydrogens would be balanced. But then I would have 2 oxygens on the reactant side, and I would have 5 oxygens on the product side. And so that's an even odd situation. And when you do that, it's good to go ahead and start with using doubling up on all of the stoichiometric coefficients. So if I do that and I start with benzene, C6H6, and I have 2 of them, then that means I have 12 carbons. And if I have 12 carbons on the left, then I also have 12 hydrogens. So I would need a 6 there. Now look, I have 12 times 2, that's 24. Oxygens from carbon dioxide plus 6 times 1 from water. That's a total of 30. And now I can use a whole number here. 15 times 2 is 30 on the reactant side instead of using fractional stoichiometric coefficients. Now, there's nothing wrong with a fractional stoichiometric coefficient. It will work as far as mathematical operations are concerned, but generally we prefer to have whole number stoichiometric coefficients. So now let's go ahead and approach the problem. It's a stoichiometry problem, so I'm going to organize my thoughts in the typical method that I do by first starting with what I'm given and writing that down. I'm given 11.713 moles of benzene. And I'm going to write down next what I'm asked for. I'm asked for the mass of water in grams. So then that means the basic plan is to go from moles of benzene to grams of water. Now, there isn't a direct path between those two things. And in fact, they're different species. And when I want to convert between species, I always do so in terms of moles, and I use the balanced chemical equation. So I can convert from moles of C6H6 to moles of water by using the stoichiometry in the equation. Then once I have moles of water, I can convert to grams of water. Now, putting it together, 11.713 moles of benzene. The stoichiometry in the reaction tells me 6 moles of water will be produced when 2 moles of benzene react. And then the last step, converting from moles of water to grams of water, is just using the molar mass of water. Sticking it into my calculator, I get 633.2 grams of water, and that is the final answer. Okay.